Hey pre-cal kids, welcome back to a new week. This week we're going to start off the week by talking about the law of sines at a more in-depth look. So law of sines, and we're going to look at a very special case called the ambiguous case. So to be ambiguous is going to mean to be unclear a little bit, and that's what happens when we do law of sines. And I want to draw you an example of why. So if we talk about the unit circle, I'm going to focus on the first two quadrants. If I rotate 30 degrees, sine of my 30 degrees equals a half. I also, instead of going 30 degrees, could go 150 degrees. So this red angle that I've drawn is 150 degrees, and sine of 150 degrees also equals a positive 1/2. So when we're looking at the first two quadrants, and the reason we're only looking at the first two quadrants is because this green line that I'm making is 180 degrees, which is the biggest degree you could have in a triangle if you had a triangle. So we're going to focus on the first two quadrants, but sine of 30 degrees and sine of 150 degrees both equate to a half. So when we're doing law of sines using sine, the trig function, and we're staying in the first two quadrants, there's two different angles that we have that could result in the same side length. So this is where the ambiguous case comes from. We don't necessarily always know which one of those two angles caused that side length, the 1/2 in this case, to happen. So the first thing we're going to do is we're going to go to page 62 through 64 in your current pre-cal book, and we're going to look at the different air quotes, cases. They're not really numbered like this in real mathematics, but we've numbered them in your book so that we can refer to them and talk about the same cases together. So go ahead and flip to page 62, and we're going to start going through these. Okay, so again, we're going to start on page 62 at the bottom, and the top of page 62 walks you through what I just explained to you about the ambiguous case, and then it says right above the line where this picture starts, so like right up here on your paper, it says we're going to fill in these blanks with a couple of things. The angle line is going to be acute, obtuse, or right. And then it says the lines about side A, side B, and H, you're going to use less than, greater than, or equal to. So let's compare these. So I'm going to label a little bit better so it's clear for you, but this is angle A, which means this over here is side A. They called this side B, and here's my height. So let's read the statement. If angle A is blank, so this angle right here, is it acute, obtuse, or right? Correct. It's an acute angle. So if angle A is acute and A blank H, so what we're comparing right here is side A over here to the height. Well, based on this picture, side A is definitely less than the height, then blank triangles exist. So I'm going to draw in here to the best of my ability. What they're saying is this little A right here, can I swing it out this way or in this way, and how many triangles can I make? The problem is, you see this red dotted line they had to make you use red. This red dotted line in here, when I swing side A back and forth, side A is never long enough to touch down here. Since it's never long to touch, I never can complete the triangle, so 0 triangles exist. Let's try cases 2, 3, and 4. Okay, so let's start up top. So in case 2, this angle A right here is acute, and A blank H. Well, look right here. A and H are labeled on the same side. So what do you think you can tell me about side A and side H? They are the same, so they are equal. If the height and side A are the same length, you can only make one triangle. It's a horrible one. Let me fix that. You can only make one triangle. It's this one right triangle where A equals H, forming this 90-degree angle right there. Okay, let's go to case 3. So we're always going to start with angle A. And I should tell you this just to make sure you understand. The ambiguous case comes from the side-side angle. Side-side angle equals ambiguous. We're never going to have an angle side-side. We're not going to talk about it. We don't put the letters in that order. But we have a side-side angle. And so when they do this, they always call the side-side angle, they always call it A, B, and then because this is across from that, they always call this one big A. These letters are not important because you can call them anything you want. We could have called it B, A, and big B, but what's important is that you understand how to construct the figure, that it's always going to be the side angle. Okay, let me erase some of this coloring. Okay, so let's go back to doing this problem. So this angle A right here is acute. B blank A. So now we're going to compare. We're going to compare side A over here with side B. So if you compare the length of side A to B, A is bigger than B. That means from this height right here, I can only swing the A side out this way. If I tried to swing the A in this way, it would be too long. It'd be longer than this line. So I only can make one triangle. So if angle A is acute and the A is bigger than B, then we only have one triangle. Case 4. So let's look at angle A first. This angle down here is acute. And then we're going to compare side A to my height. Well, it seems that A is a little bit longer than the height because the height is the straight line, the shortest distance between 2 points, and A is a little bit bigger. So A is bigger than H, but this side A that we have here, or here, there's 2 A's in this picture, they're the same thing, it is less than B. So when H is smaller than A and A is smaller than B, then I have 2 options. I can swing side A out and make this green triangle that I was talking about, or I can swing side A in past the height and make this triangle that I'm talking about. This is the ambiguous case. Because this angle in here and this angle in here are like my 30 degrees. That would be the 30. And because this one's obtuse, this would be the 150 degrees, where the sine value is exactly the same. So again, if angle A is acute and side A, this side over here, is between H and B, then we're going to have 2 triangles. And this is the ambiguous case. Okay, one more page. Go to page 64. Let's talk about 2 more cases we could have. Okay, these last 2 cases are a little bit different because let's look at angle A. Angle A down here is definitely now obtuse. So this is why we look at the angle first. When we look at the angle first, we know whether we're going to be on pages 62 and 63, cases 1 through 4, or if it's obtuse, we go straight to page 64. So if angle A is obtuse, and then this side A compared to side B, what can you tell me about this little side A compared to this big side B? A is, that's right, A is less than B. Or if A was equal to B, if they were the exact same length, the second that I tried to rotate out this way, I would be a little bit short. So that's why the or is there. Or A equals B, then we have 0 triangles. We can't make any because we're never going to be long enough to touch the line down here, ever. Okay, case 6. If angle A is, what is this angle right here? Angle A is obtuse. And then we're going to compare side A to side B. What can you tell me about side A to side B? That's right, A is bigger than B. Then we only have 1 triangle. It means we only can swing the A this way out. If we tried to swing A this way, we would be changing angle A at the bottom, and we're not allowed to do that. So we only can swing it out to make this big green triangle right here. Okay, so let's walk through a couple of these problems so that you can see how this works. So we're going to skip to page 69, and we're going to do the left-hand column where you're just determining how many triangles can be created. Okay, on page 69 on the left-hand column, we're going to just state how many triangles can possibly be made. So first of all, let's just talk about this again. The ambiguous case happens when I have a side-side angle. So side-side angle. So side-side angle. Doesn't matter up here what they labeled them as, but that's how we're going to make the triangle happen. So let's do... So the angle they give me is C. So this is C, and this is 63 degrees. If this is big C, the angle, then across from it is little c, the side, which is 12. And then we have to make our other side here B equals 9. So the questions you should ask yourself are, 1, angle is blank. The angle they give me is acute. So we're looking at cases. This symbol that I'm drawing means therefore. Therefore, cases 1 through 4. The next thing we need to find once we do that is the height, because in all of cases 1 through 4, it compares my sides to the height. So let's talk about how to find the height for a second. I'm going to draw the height in right here. So if I want to find the height right there, I have this right triangle that I'm outlining in blue. So what I can do is, it's always side, sine this angle. Side times sine of the angle. And this side and this angle right here should not be the same letter. So in our case, it's going to be 9 sine 63 degrees. So I'm going to grab my calculator real quick, and I'm going to type that in so that we can find out what the answer is. So I made sure my calculator was in degrees, or you can put the degree symbol, but you're going to do 9 sine 63. And it's going to tell you this length, this height. This is going to make my height, this thing right here, my height, is going to be 8.01906. I'm going to write all the decimals down, so I'm about to compare sides. So now I need to compare this, grab a different color really quick. Now I need to compare this side over here to my height. So this side that I have over here, in our notes it's called A, and this picture it's called C. It doesn't matter. This, we call it the swing side. The swing side, the side that could swing out or maybe in, is bigger than my height. So in your notes it's going to say A is bigger than my height. So that means I could maybe swing it in or out because I'm going to be longer than the height, so I could go in or out. But now we need to compare this 12 to the 9, the side B. So right now what I'm looking at is on page 63, because this swing side over here is bigger than my height, I'm looking at either cases 3 or 4. It can't be case 1 because this swing side over here is not smaller than my height. It doesn't equal my height, so I'm not case 2. So I'm either case 3 or case 4. A in this case, again, which we're calling C, is bigger than my B, which means I could have stopped at case 3, because since 12 is bigger than my 9, my only option is to swing this out, not in, just out like this. So that means I only can make one triangle, which is case 3 in your notes. So let's try another one. Let's try number 2 on page 69. So it tells me that the measure of angle B equals 33 degrees. A equals 27, and side B equals 22. So again, always side, side, angle. So this angle in here, which we're going to call B, is going to be 33 degrees. So question 1. Angle is blank. This angle is acute. So that means we're down to cases 1 through 4. And now we have side, if this is side B, then across from it is, sorry, if that's angle B, across from angle B is side B. So this is 22. And then that means this is A over here, it's 27. This is A, this is B. So let's compare A and B. In this case, B, my swing side, is smaller than A. That means I possibly could swing it out or swing it in, but I don't know if I can even touch the bottom down here yet until I find the height. So let's find that height. Height is always going to be side, sine, angle. Side, sine, your angle. So in my case, it's going to be 27 times sine of 33 degrees. You can either make sure you put that degree symbol in or change your calculator degrees. Either way will work. So 27 times, press that trig button, grab sine 33, and then I like to put the degree symbol. That height right here, this height right here that I have to be at least that to make any triangles, it's going to be 14.7053. That means B, my swing side, is greater than the height. So I can make a triangle, and because B is less than A, I can swing it out and make this triangle, or I could swing it in and make this triangle. This is an ambiguous case. You can make 2 triangles. Let's try another one. Let's try number, I'm going to skip number 3. Let's try number 4. So now we're on number 4, and it says that B, my angle B, is 95 degrees. It says that little b, my side, is 24, and that little a is 5. Again, remember, always side, side, angle. But in this case, I need to draw a little bit more accurately, and here's why. Let me cross that one off with red. This angle is obtuse, so it's going to be side, side, and then this is going to be my obtuse angle down here. So my angle B down here is 95. And so the first question this time is angle is blank. It's obtuse, which means we're looking at case 5 or case 6, but not 1 through 4, because my angle is obtuse. And so if this is angle B, then this is side B over here, 24. That means this over here is A, which is 5. So this means that I can make 0 or 1 triangle. The answer is 1, because B is bigger than A. This is my shorter distance, so I can swing B out this way and make my triangle. So because 24 is bigger than 5, I can make 1 triangle. Okay, so now I'm going to go back to page 67, and we're going to walk through the math to not only figure out how many triangles there are, but then find the missing pieces. Okay, so on page 67, we're going to start the exact same way. First, we have to determine how many triangles we can make, and so that way we have a game plan on what we need to do. So on page 67, number 1 says that big B, the angle B, is equal to 22 degrees, and that little b equals 16.8, and that little a is going to equal 22.42. So the first thing we're always going to draw is that side-side angle. This is an acute angle, so side-side angle. We know in here that this is 22 degrees, that's my B, which means across from it is 16.8. So this was big B, this is little b, which means A goes over here, 22.42. So, number 1, angle is blank, it's acute. So we know we're looking at cases 1 through 4. We know that this side over here is less than this side over here, which is a good thing or a bad thing. We're going to find out in a second because we need to also find our height. So let's find our height. Our height is always going to be side, sine, our angle. So side, sine the angle. So my height is going to equal 22.42 sine 22 degrees. Just type that in your calculator. You're going to get that your height equals 8.3986. So that's that minimum distance right here. This is the absolute minimum distance I could be. So if you're looking at your cases that are on, we were at 1 through 4. So because 16.8 in my swing side is, and then I have my height, 8.3986. So because this was A and this is H, so A is bigger than H, but A is less than my B, which was 22.42. Hang on, I'm going to fix these labels for you. So this was my height. In our case, we did call this one B, but it's the swing side over here either way. And this was less than side A. That means I can swing or I can either swing this side out and make that triangle, or I can make this triangle. Because my green side is bigger than my height, but smaller than this side over here, then I can go out or in. And so now we're going to do the math to find all those missing pieces. But now at least we know 2 triangles. So let me grab a new page. I personally like to do this in a table. It makes things come out a lot easier for me. So what I always do is I'm going to do one triangle, then I'm going to do the other triangle. So let me split this in half because it's all going to connect to one another in a second. Oops. So the first one I'm going to find by default, I'm going to call triangle 1. So what we know right now, I'm just copying out the problem, is that big B equals 22 degrees. We know that little b equals 16.8, and that little a equals 22.42. So because I have a complete ratio, let me use my highlighter. Because I have a complete ratio, right here and right here, I can go ahead and use that, and that's what I'm going to do. I'm going to use the law of sines. So I'm going to do sine of 22 degrees over 16.8 equals sine of angle big A over side A, 22.42. And what I'm going to do is I'm going to cross multiply and then divide. So it would be sine A equals, you would multiply the 22.42 times the sine, oops, hang on, let me erase that and fix that. It's supposed to be a multiplication. Times sine of 22 degrees, and then you would have divided all this by 16.8. So I'm going to type that in my calculator real quick and get an answer, but that's not going to be your final answer. So I did control divide and got a fraction. On top, I'm typing exactly what's on the paper. 22.42 times sine of 22 degrees, all divided by 16.8. It's going to tell you this is going to come out to be 0.4999 repeating, but we need to solve for A. So in my calculator, I'm going to have to do arc sine of my answer, the 0.499921. And if your calculator's in degrees, it's going to give you a degrees answer. So I highly recommend that you put your calculator in degrees. And so when you type the arc sine in the calculator of the 0.499921, you're going to get big angle A. And big angle A is going to be 29.995 degrees. We always go to 3 decimals. I'm going to box that answer. And then I'm going to grab a different color so we can color code all this. Now I know 2 angles. So if I want to find big angle C, I can do 180 minus the 22 for angle B minus the 29.995 degrees. And this will get me my angle C, because a triangle has to add up to 180 degrees. So we get that my big C is going to be 128.005 degrees. I'm going to box that one too. Box the C that goes with it. So now that I know angle C, I finally can find side C. So let's go ahead and do that. So I'm going to grab, I don't know, we'll do red now. So I'm going to do law of sines again. One note, I would not use angle A. If you made an error in finding angle A or you rounded funny, that rounding will be introduced to side C when we find it. So I always go back and try to use the original ratio they gave me so I don't introduce more error. So I'm going to do sine of 22. I'm copying pretty much what I wrote in white up top. Sine of 22 degrees over my 16.8 is going to equal sine of 128.005 degrees all over side C. I'm going to grab my blue for a second. Be careful, or just make a note. This one right here where I'm putting my blue dot, I had to find an angle, so I had to do the arc sine. This one, I'm only finding little side C, and because I'm finding a side, I'm not going to have to use arc sine. So when I cross multiply, you should get 16.8 sine, cross multiply, sine of 128.005 degrees, all divided by sine of 22 degrees, and this is going to give me little side C. And so I'm going to go ahead and type that in my calculator. Control divide, 16.8 sine of the 128.005 degrees over sine of 22 degrees. And you found out that little side C is 35.338. Now, the reason I told you to do this in the table is the following. They go together. The answers and the work go together. So I'm over here, I'm going to write triangle 2. When you do triangle 1, you are always finding this version that you swung it out. Let me draw the height in there. So you swung the swing side, this side over here, out. So when I go over here, I'm always finding where I swing it in. If I'm finding the skinnier triangle. And so that means this angle, let me grab a color really quick. Let me do yellow. This angle right here and this angle right here, they're the two that go together. And this is angle A. And so this was the acute angle A, and this is the obtuse angle A over here on triangle 2. And so what's going to happen is that I am going to use what I talked about at the very beginning of the video, the sine of 30 and sine of 150 have the same sine value. So what we're always going to do is take this first angle that we found. I'm going to color code it. So I'm going to grab my yellow because the first angle that I found was this yellow thing, the A. And I'm going to do 180 minus my 29.995 degrees. Because this angle A and this angle A right here, they have to add up to 180 to make that first quadrant, the 180 degrees that I had before. And so this is going to be what I call A new. So I'm going to do that in my calculator. I'm going to do 180 degrees. So 180 minus the 29.995. So my A new is 150.005 degrees. And then I'm just going to follow what I did. So when I found angle C before, I did 180 minus 22 minus 29.995. Well, I don't have 29.995. I have this. I have 150.005. Same thought process though. So C new, exact same math, 180 minus the 22 that I had from angle B that I can never change, minus my A new, 150.005. That's going to get me my C new. So C new, if I use my calculator, it's going to be a very small angle, 7.995 degrees. So here is my C new. And then finally in red, I'm going to do the exact same math I did right here, except my angle is going to change. So I still have sine of 22 degrees over 16.8 equals, I don't have 128. I have my C new up here. I have sine of 7.995 degrees all over little side C. So 16.8 sine of 7.995 degrees all divided by sine of 22 degrees. Everything lines up and it's the same except for that 22 stayed the same, this stayed the same, but this right here, let me grab a blue, this one right here and this one right here, they affected and changed one another. So it's almost exactly the same math. Oops, sorry. Still writing in a highlighter. So let's grab the red pen. I'm going to type this in my calculator, use my little fraction tool. And if you're using some logic, since the angle C got way smaller than side C should be way smaller. So instead of being 35 something, this time I got it to be 6.238. It's little c. So this is how I usually find two triangles. Okay, let's do the next two examples on page 67, and then tomorrow you are free to work on your practice problems. Okay, so again, we're still on page, I lost the page, I think 67. Yep, we're still doing practice on page 67, so page 67. Now I'm going to do number 2. So number 2 tells us that big angle B equals 96 degrees, little side B is 3, and little side A is 24. It's an obtuse triangle, so we're going to draw side, side, and we're going to make this angle down here obtuse. So this is my 96 degrees. It was B. That means this over here is equal to 3 because little b is across from big B. That means this side right here is A, and it's 24. So question 1 is the angle is obtuse. So we only have 2 choices. Once you're obtuse, you either have no triangles or 1 triangle. So we have to compare this side to this side. And we want this side to be longer than this side so that it can reach the bottom down here. But in our case, B, which equals 3, is smaller than A, which equals 24. So I'm never going to reach the bottom. So there are no triangles. And there's no math for you to find because there's no triangles, there's no missing sides to find, and that is it. So last problem, number 3. Check. Oh, I did 67. Good. Just number 3, again, still on page 90. Oh, not 90. I did that in the last slide. Let me go back and sure. Okay. It should be page 67. Number 3. They tell me that little a is equal to 7, little b equals 9, and that big B equals 49 degrees. So again, this is acute, so we're going to draw it the right way. So side, side, angle. I drew an acute angle. This is 49 degrees. It's my big B. Little b is going to be across. It's 9. A equals 7. And then I'm going to draw my height in. So because we can look at B and A and say that 9 is bigger than 7, I'm either going to have 0 triangles or I'm going to have 1 triangle. I can't have 2. Oh my gosh, I can't spell triangle either. Let me fix that. 1 triangle. And this is why. Because this one's bigger, I can't swing down this way. It's got to be shorter. So I could have 1 triangle by swinging it out this way, but I have to find this height to see if I'm even long enough to go that way. So let's do that. So to find my red height, it's always going to be side, sine, angle. So in our case, it's going to be 7 sine of 49 degrees. And when you type that in the calculator, you should get that your height equals 5.283 approximately. So we know we're going for that 1 triangle because this side B is longer than my height, so I can swing it out and make my 1 triangle. The beauty of that is that when you get 1 triangle, you're going to pretend like you don't know the ambiguous case exists, and you're just going to solve like you did earlier all of your problems last week before you even knew this ambiguous case existed. So let me just shrink this down really quick, put it in the corner. I'm just going to do math. So my complete ratio is the B. So I'm going to do, I never put a degree symbol up here, I'm sorry. So I'm going to do sine of 49 degrees over 9 equals sine of, or we'll call it big A because it's across from little a, 7. I'm going to do my cross multiply, make a butterfly. So I'm going to get 7 times sine of 49 degrees divided by 9 is going to equal sine of A. Because you have a sine here that you're trying to solve for, we are going to have to use that arc sine. So in my calculator, I'm going to type the 7 times 49, either put your degree symbol or put your calculator in degrees, and then divide by 9. You should get this piece right here is 0.587. This equals sine of A, so we have to arc sine the 0.587 to get my angle A. If your calculator's in degrees, it'll give you the degree answer. If not, you're going to have to convert it to radians by, or convert it from radians to degrees by multiplying by 180 and dividing by pi. So you're going to get the big A equals 35.944 degrees. I always like it when you box these along the way because it makes it easier to find your work and your answers. Let me shrink that one down a little bit. So there's angle A. And now that I know angle A, I can do the 180 minus the 49 they gave me minus the 35.994 degrees. And this is going to get me angle C. So you're going to get that big angle C is going to be 95.056 degrees. And I'm going to do a law of sines one last time. Again, I'm going to go back to my original ratio up here and not use a rounded answer. So I'm going to do sine of 49 degrees over 9 equals sine of 95.056 degrees over little c. And so when you cross multiply, you're going to get 9 sine 95.056 degrees over sine of 49 degrees equals little c. You won't have to arc sine because you're solving for a side this time. You only have to arc sine when you're solving for an angle. So let's type this in our calculator. 9 times sine of 95.056, degree symbol, over sine of 49 degrees. And you should get that side C is 11.879. And you're all done. Hopefully this helps you guys. Remember, your teacher has office hours, and then you can go back to Canvas and work on the practice problems or options that you have for the assignment for this part of the unit. Happy math, kiddos!